This is your host, Andy Chin, back again with another episode of Business Logic.
The two key parts of guided struggle are guidance and struggle. You need to struggle, and I think the workplace is a great place to struggle because firstly, someone's paying you to do it. And secondly, you're going to spend that many hours in your day anyways in this place. Might as well be a context where you have these motivating kind of challenges.
That was my guest on today's show, Oz Nova, the founder of a computer science school in San Francisco called Bradfield. Bradfield's mission is essentially to allow software engineers to pursue mastery, to take classes that let them fill in their knowledge gaps and reach their maximum potential. So before I talk more about Bradfield and Oz, I want to back up and give you some background about how I heard about him in the first place. So I have this friend who is extremely talented as a software engineer, and he also has a somewhat non-traditional background where he basically skipped college altogether, went straight from high school right into industry, and started working for top companies right away. He's a completely self-taught software engineer, but at some point he realized that he'd hit a wall where he wanted to fill certain knowledge gaps and needed a place to do it. And he found Bradfield. And he was able to study things like databases and operating systems and computer architecture and things that are typically a little bit harder to self-study. So hearing this, I thought whoever's running this Bradfield thing must be a pretty darn good teacher. And being a good teacher is really kind of this undervalued skill in the workplace. People who can teach really well are typically great mentors, and they can usually have much greater impact when people are comfortable coming to them with questions or prefer to come to them to bounce ideas off of. So these all seem like qualities that I thought, okay, that's what I want to learn, and I want to talk to the person who runs Bradfield. And that's how we got to today's episode. So without any further ado, this is my conversation with Oz Nova. Hello, Oz. Welcome to Business Logic.
Glad to be here.
So I am super excited to have you on the show. I think maybe a lot of listeners will have the question, who is Oz Nova?
Okay, so I run a small school in San Francisco teaching computer science to software engineers. I've been doing this for 4 or 5 years. Prior to that, I worked mostly in startups, helped start a couple, Top Guest, Vita Health, worked as their CTOs, worked in some somewhat larger startups, really a mix of software engineering and engineering management roles for 10 or so years prior to starting the school.
What would you say you do today? It's almost like that question from, what is that one Mike Judge movie, Office?
Oh, I'm very bad at pop culture. I should just lay that out there.
Yeah, there's that one movie where there's that meme, like, what exactly do you do here?
Yeah, I asked that question myself. So in the evenings, I teach. Most evenings, I'm teaching a computer science course of some sort. I teach a lot of our systems courses. So tonight, I'm teaching a computer networking class. Yesterday, I taught a computer architecture class. During the day, I am working on some interactive online courseware, playing with my kid who is 7 months old. Yeah, that's it. I train jiu-jitsu. That's my day. Wake up, record some videos, play with my kid, train some jiu-jitsu, come in and teach some computer science.
Fascinating. Seems like a pretty standard mix of, teaching CS and martial arts.
It is way better than a day job. Let me put it that way.
So you also, I don't know if you mentioned, you also host a podcast.
I do, yes.
Of your own.
Yep.
It's called Escaping Web.
Yes.
What's behind that name?
We're just trying to be kind of provocative. I think there are a lot of software engineers who feel like the web is the final platform, whether they realize they recognize this or not. Like they implicitly in their decisions or what they learn and what they do with their careers, they act as if we will always have the web, that the web will be the most valuable platform, that the kind of trend of technologies that they see is going to keep going like this indefinitely. And we think that's not the case, that there is much more to software engineering than just web application development, and that this will be an increasing thing, and that there will be other dominant platforms other than the web, and maybe relatively soon. So the idea of the podcast is to highlight people who've made this transition maybe from web development to something else, some other kind of software engineering potentially, or move somewhere else in their careers. And also to just kind of explore what that next big platform may be and what that might look like.
So to help listeners get a sense for like how people have escaped web, what are some examples that come to mind? Like how does one leave web development?
Yeah, well, actually, there was a guest who we had recently who's a colleague of yours, Grant Wu. I don't know if you saw this episode or know Grant, but
I think, yeah. He works on developer productivity stuff.
Yes. Yeah. So, he was doing web development. He was a self-taught engineer, a bootcamp grad, and was doing web dev work, and started taking some courses with us, and kind of got hooked on operating systems in particular, and just low-level programming overall, and decided to quit his job. Spent over a year hacking on a little operating system, writing a small compiler, really just trying to get a kind of foundation in systems that he didn't previously have. During that time, he made the resolution that he just wasn't going to go back to web development, that this kind of work was more interesting. And so at Stripe, he works on language tools. I think you guys have a like Ruby static type checker or something, and tools along those lines. Working at a bit of high leverage. Obviously, Stripe still has a web application. Mm-hmm. They're not abandoning the web in any way, but there are people at the company who work on the website. There are people in the company who work on the web platform, the API, and so on. And there are those who work with a little bit more leverage, perhaps on other kind of systems level tools. And Grant decided to make that journey. He got obviously an offer from Stripe, but also like an offer from a company that made persistent storage devices of some sort. I forget which one. And he would have been writing firmware. And so this was the kind of journey that he made.
So when I see the name Escaping Web and I see sort of the description to imagine a future where web isn't the dominant platform, I wonder if there is a critique there of industry where maybe it's the case that people study computer science, which is like this fascinating, multifaceted, really deep subject, only to go do web development as a career. Yeah. Is there some sort of value judgment there about the kind of work that doing web work does?
I'm not sure about that. I think the people who are very, very good at web work understand computer science very well and get to actually apply a lot of their understanding and principles. But that just does not characterize or like correctly summarize the experience of most of the people who are working on the web as a platform. So you can absolutely, even let's say you're a front-end engineer, if you're trying to be the best front-end engineer, you cannot do that without having a very, very good understanding of both the like theory and system side of computer science. But it's just not very many people who are in those kinds of roles. So I don't mean to make a value judgment there, but I think software engineering as a profession can be incredibly rewarding. It is not so rewarding if you do repetitive, routine kind of work, and a lot of web development does become that over some time because we try and reuse tools, we try and reuse other people's stuff, and so a lot of the time we just end up translating business needs into CRUD apps, and this isn't, you don't need computer science for that,
right?
But you can use computer science for a lot of software engineering. I think that's what we should strive for. Sometimes that's in the web, but a lot of the time that's outside of it.
I mean, if I was to take a super reductionist view, this is not necessarily what I believe, but if you think of someone who got a master's in computer science and then now like positions divs for a living, that just seems kind of sad. Why do you think that is? Like, why is it so lucrative to work on not super engaging work? Like, wouldn't you think it'd be the opposite? Like, you're paid to use your brain.
So I think an aspect of it is that a lot of the more interesting roles in software engineering are popular. So take game development, for instance. It is more interesting. It's more demanding. You're in a soft real-time context. You've got to hit your frame rate, and you're working at a lower level, and perhaps most importantly for a lot of the people who are working on it, you are actually making a thing that you enjoy playing. And so there's a lot of demand, there's not as much supply. And so the kind of overall proposition for someone looking at it from a career perspective is worse than web development. So I think that's an aspect. And then also, I think we're just at a period in the evolution of technology where it is incredibly valuable for a typical Fortune 500 company to embrace the web and do more on the web, expose more of their business over the web, sell more of their products over the web. And so we're just at this like unique time where we cannot have enough software engineers
right
working on web applications. So that means that salaries get inflated. It means that you can do a 3-month boot camp and get a job. You can get a pretty lucrative job. And so we see a lot of people going into web development as a consequence. You can't really do a 3-month boot camp and then do systems work or work on the code for a 747 or a Tesla or something. So that's an aspect of it as well.
Right. I heard a story, it might be apocryphal, but I mean, you said 747 there, and I thought about how that I think the software engineers behind the 747 tested in production by literally live coding fixes to the firmware of the plane while they were in it.
I've not heard that story. I've not.
Okay. I hope it's real. That'd be the coolest thing, and also the most terrifying job ever in engineering.
Yeah, I mean, you got to write good code if it's running on a plane.
Yeah, if you're literally sitting in the plane and like making adjustments to how, I don't know, the wings work as you're landing.
Yeah.
That's largely true from what I see, where it just so happens that we're at a point of history where a lot of companies are either waking up to software or they're in this mass migration from things that used to run on-premise and proprietary like data center stuff to the cloud. And it just so happens that unlocks like a lot of jobs. But maybe it's not going to be that way forever. And it seems like that's part of the thinking behind escaping web and a lot of things you're doing. If you had to place bets for the next dominant platform for development, where would you put them?
I mean, it's hard to imagine the future concretely like that, but there is a potential scenario where, let's say Apple comes out with basically the visual equivalent of AirPods, an AR, like a head-mounted display, which is very good, which is like, maybe there are going to be a couple of iterations, iPod style, where we gradually build up to something that everyone wants. But eventually there's an Apple quality AR device that everyone is wearing around in the same way that everyone wears AirPods. And if that were the case, if that display technology is good enough, then you can see that replacing everything with a display, right? Because if you can project an image onto someone's retina directly, then it's really wasteful to have a physical display at arm's length or, hanging on a wall or something and send the image that way. And so what does that mean? Potentially phones, tablets, laptops, desktops, televisions, anything with a display goes away, and then we have this like head-mounted display as the one display technology, and so its platform becoming particularly dominant platform. And then the question is, will we just take like a browser and put it on the like Apple glasses or whatever?
Right.
And I suspect not. I suspect that the web doesn't translate very well to that kind of environment, so that we're going to expect to see 3D things rather than pure 2D projections. We want to be able to walk around things. We want to see it interact with our physical world and interact to some extent with it. We want the response of like reaching our hand out to it. So I don't think we're just going to take websites and put them
just project them right in front of us.
Yeah. So what does that platform look like? I think it's incredibly different to the web. It's not, web development is about concatenating strings. Ultimately, like we just have a whole bunch of technology, which, from database to web server through caching layers and whatever, just concatenates a bunch of strings together, delivers it to the browser. Browser interprets some kind of tree in there. And then we render this in a 2D way. And that's absolutely not what what 3D graphics is about. 3D graphics, if I were to summarize it in such a flippant way, it would be matrices of floats. And this is a totally different set of primitives, right? We model 3D objects with matrices of floating points, and we have projections of these things using matrices of floating points. And if these things are not familiar to you, which if you've been just concatenating strings for your whole career, they might not be. If you're not thinking about running on the GPU or maybe custom hardware by that time, rather than like general purpose CPUs, it's very different context. The languages that are used are different. The constraints we're already talking about, the kind of soft real-time constraint of this, they're very different. Maybe this thing is going to run at 120 frames per second or more. You've got very little time to render a frame. Yep. Quite different to the context of web, where you're like, if the page takes another 100 milliseconds to render, what is that in the context of, them requesting the page 300 or 500 milliseconds or something like that. So, you move from the hundreds of milliseconds to the tens or even individual milliseconds and kind of time constraints. So all in all, a very different platform, I think, to the web.
Would you be excited by that sort of future if there's like this greenfield area of development?
I would for sure. Yeah, I would for sure. I feel like personally, the web was the dominant platform of my career, except that I arrived at it just a little bit late. Yeah. And so it was kind of already a stage of maturation before I showed up. Whereas this thing, it is a green field. Mm-hmm. I think it will reward people who are very creative, people who are not satisfied with the kind of diversity of technological products that we have on the web, and who want to create something that is more interesting, more compelling, more interactive. So that's exciting for me for sure.
Yeah, I personally think that would be the kind of future that we'd want. Like it'd be very science fiction-y for sure. Yeah. Which, I think would be in stark contrast to, well, this is starting to get into my own beliefs here, but in school, I think you're inspired by all the possibilities. And like universities are very much about like what's cutting edge, what is next. Yeah. And that vision of the future is very science fiction-y, exciting. Not to say that like the one that we have right now is not, but it's certainly like, I guess, less heterogeneous than I would have expected.
Yeah, I mean, you look at all this fascinating stuff, and then you start interviewing, and all these companies are just string concatenation companies when it comes down to it. Just like string processing companies. You learn all about algorithms, and then you go into the industry, and it's a rare and special occasion when you get to use something that you characterize as an algorithm. Right. It's kind of indicative of where we are.
Yeah. I mean, okay, so now we're talking about how we learn stuff, which is a perfect segue into kind of your main job nowadays, which is teaching computer science classes here at Bradfield, the school you founded.
Yes.
Before we go into like the details of that, I'm just curious, like, what was your own learning of computer science and programming like personally?
Yeah, so it was not a clean kind of journey or narrative. I learned to code when I was very young. I was lucky that way, but it was always a hobby. I was always discouraged from pursuing it professionally at the time. I mean, it's strange to think about this now because software engineering is so lucrative. But at the time, you wanted to be like a lawyer or a banker or a doctor or something. These were the professions. And people thought that software engineering, where I'm from in Australia, they called it IT, that IT was a commodity. Yeah. We had this big outsourcing boom. There was prior to that a kind of scare, a belief that all the interesting work was moving to Japan, that there was a kind of race to the bottom in software engineering. So I was always discouraged from pursuing it professionally. I ended up majoring in mathematics. Part of that was because I just had no idea what I was doing, and I found mathematics interesting. And part of that was because there aren't a lot of good computer science programs in Sydney. And I did some computer science as part of the math program. Was always just coding for fun. And by the end of my degree, it was pretty clear that I should be in software and that software is going to work out, that is going to be reasonable to be a software engineer and that you'd make enough money that way. And that despite not ending up with a computer science major, that everything was going to be okay. So that was my journey. Ended up self-teaching a lot of the computer science, particularly the system side of things. I think I got enough coverage of theoretical computer science in a kind of more formal context, but I didn't take an operating systems class or a databases class or something like that. That all ended up being on the job.
So I'm wondering then how much of your own education and your own learning it for the first time informs how you teach now, because you mentioned that a lot of yours was self-taught. It's almost like a then question: why do we bother having classes? Period.
Yeah. So I think learning is ultimately guided struggle. And, the two key parts of guided struggle are guidance and struggle. You need to struggle. And I think the workplace is a great place to struggle because firstly, someone's paying you to do it. And secondly, you're going to spend that many hours in your day anyways in this place. Might as well be a context where you have these motivating kind of challenges. And so people learn a lot on the job as a consequence. But the other aspect is guidance. And if you are in a context where not only are you struggling to do things and thereby learning, but someone's kind of curating the journey a little bit for you, or picking the next challenge, or suggesting the next resource or next objective, that's the kind of ideal scenario in my perspective. So when we were setting up Bradfield, it was in the context of having learned a lot of computer science just in time, as needed on the job. And so having it be motivated, but recognizing that that was not the best way necessarily to have learned it. Also that a traditional university, like a tertiary treatment of the material, is also not the best way to learn it. So, we try and teach it with that context of industry, but we do think that we can teach in a 6-week course what might take you years to pick up piecemeal on the job.
So what sort of classes are offered here, just to let you plug it?
Yeah, so we offer a lot of the courses that you would see in a conventional undergraduate computer science program, more on the system side of things, but some of our most popular courses are, we have an algorithm and data structures course, not surprisingly, it's quite popular. But also a computer architecture course is very popular. I think probably the only popular computer architecture course outside of a university.
So true.
And maybe, really the only computer architecture course.
Yeah, does anyone teach that stuff outside of college?
Not really. Not that I've seen so much. Obviously, there are free online courses and that kind of thing. There are great textbooks. But in terms of an environment where you have a teacher and some kind of guidance in this journey, mostly universities are kind of equivalents. So those kinds of courses. But networking is also popular. We have a databases course, a distributed systems course. So, undergraduate through to maybe early graduate coursework, master's kind of program courses in computer science.
Why did you start Bradfield in the first place?
So I started Bradfield with a friend of mine. We both went to school in Sydney, and we're both pretty unhappy with our kind of tertiary experience of computer science. Like I said, I ended up taking a math major. Miles dropped out of his program just because he felt like he wasn't learning anything. I think it was best summarized by his experience of learning computer networking in a course that was sponsored by Cisco. So it's kind of like the Cisco Routers guide to computer networking. Man. Anyway, so he just dropped out and went into industry because he didn't see the point. But we both had a bit of a chip on our shoulders, I think, about how to teach computer science well. And Miles kind of accidentally became the CTO of Dev Bootcamp at one point. And, so obviously he moved here. I also moved here independently. He found himself in this role in really one of the very first boot camps. And that gave us a bit of a vantage point into this huge boom that was happening at the time of this like semi-formal, a structure for self-taught engineers, a short, I think it was 8 weeks or 9 weeks at the time, maybe 12 week program to get someone from almost zero to productive and employable as an engineer. So in seeing this boom, we noticed that firstly, there was an opportunity to start a school where if you were to cater to this kind of group, Now, you're not competing with every other university trying to cater to 18-year-olds. You have a kind of niche. There's a ready market for people who are self-taught, are working as software engineers, but who want to learn computer science and shouldn't go to university for that. Who are employable and don't want the opportunity cost and the extra tuition and so on of being a 25-year-old spending another 4 years going to university. So that was our opportunity that we kind of saw. And another aspect of that is that Miles, in his role, knew what these students were learning, and what they were learning was just enough to get a job, just enough to start being productive. We saw that these folk would hit a point a couple of years in where understanding computer science would be very valuable for them. So this was the motivation, like seeing that we could provide value to this particular group of people originally, and that this was our avenue to create a kind of institution that we wish we'd had at the time.
Seems like there is a lot of thinking there with respect to what the ideal school and teaching experience would look like.
Yeah, we can only say that we're trying to aim for the ideal for our kind of students. And
yes.
Our kind of student is a self-taught engineer a couple of years into their careers. But, if you were to try to come up with a computer science program from scratch, from first principles, you would not end up at a 4-year program that you enter as an 18-year-old, perhaps never having done any programming before, where the only exposure you have to industry is the occasional internship if you're lucky. Right. And you learn foundational concepts that you couldn't imagine using for the next 5 to 10 years.
Yeah.
There's not the kind of context you would imagine. That's not the ideal that you would come up with. You wouldn't come up with an institution that's mostly based on the delivery of lectures, for instance, mostly taught by researchers in this area. This isn't what you'd come up with if you were designing the system from scratch. There's a lot of path dependence. We already have these institutions. They already have researchers. They're already 4-year programs. They're already accredited by certain accrediting bodies that expect 4-year programs and graded courses and so on. There's a kind of existing structure there. So by just eschewing all of that, saying we weren't going to be accredited, we weren't going to cater to primarily to recent high school graduates, we got to think about a lot of that stuff from scratch.
Could you walk me through then the sort of first principles reasoning for how you arrived at where you are now?
Yeah.
Starting from scratch.
Yeah. If you ask yourself, what is a good way to learn these things? You need motivation, which primarily comes from context. It does not, in my opinion, come from like charismatic teaching. This is a stopgap measure that some teachers try and use. But primarily, if you have sustained motivation, that's because you want to solve the kind of problems that this knowledge gives you. So what is an implication of that? We ought to teach the kind of computer science which is, at least in principle, valuable or usable. Maybe not to you right now, but soon, hopefully, that you can relate to work that's going on. Maybe not work that you're assigned at work, but that your colleagues are, for instance, that you would like to be doing. So this is the kind of a contextual teaching that we like to do. We're still teaching foundational computer science, but is the kind of thing that you can see yourself using as a software engineer. So that's an aspect of it. We think that learning is best done actively. Like I said, learning is guided struggle. So we want students to struggle. We want students to work on problems. Not to say that the struggle is going to be painful. We want you to enjoy the struggle, but you should be struggling through things. And what does that best look like in computer science? In my opinion, it's best done through writing code, through building things. Maybe writing a lot of code and building something significant. So, for instance, in our databases course, you build a simple relational database management system from scratch. Just like you start, you build a query executor, you build a B tree, you write the join algorithms. So this is a significant system. Sometimes it's through writing a small amount of code just to probe an existing system, but it's still like directly interacting with technology in the way that how as a software engineer. So this is a kind of another aspect of where you get to if you just say, well, from first principles, what's the best way to learn? You should be actively engaged with this thing. Mm-hmm. What's the best way to be actively engaged? What are the best feedback loops? Well, write small programs and so on.
How do you think about the balance between sort of guided struggle and just like struggling to the point of being discouraged and, I guess falling out of love with the subject because it just feels too hard or seems too hard?
Yeah. So, that's kind of the responsibility of the teacher, I think, to calibrate the challenge. It's like if you were a tennis coach, your job is to feed the ball. And if the ball is moving too fast or too slow or something, then they're not going to be able to hit it back, and it's going to be frustrating. And so that's your job. You just need to like feed the right challenge at the right time. In my opinion, that's the primary thing, like calibrating the exercise. And if you were to just like take the art of computer programming and put it on your desk and turn it to page 1 and try and start working through it and do the exercise and whatever, it's not going to work out, because it's a reference book. It's not an exercise book. It's not designed for someone to like do challenges at a, well-calibrated, sequenced manner. So it's likely that you'll be frustrated. But if you do it in a context where someone is guiding you, giving you the next challenge, the next question, the next objective, then it's much more likely that you're going to work through that.
So you mentioned at the beginning that something new on the horizon for Bradfield, in the sense that you're bringing the class online, or just starting to, rather?
Yeah, so we've kind of got 2 projects going on. One is to offer all of our courses in a live online format. And this is basically take an existing in-person course and run it over Zoom, and basically try and do everything that we would in person, but with Zoom. And this has worked shockingly well. I say shockingly because people have been asking this for a very long time. I've been reluctant. I just did not believe that we would be able to deliver online a kind of experience comparable to what's in the classroom, but it's been a huge hit. So we're gradually moving to offering all of our courses in this format as well. And then the other big project, and this is my like main personal project right now, is to offer all the courses in a fully self-paced online interactive manner. So, our live online classes are still instructor-led. It's a Zoom call instead of an in-person conversation, but otherwise it's still what you'd imagine a seminar style class to be like at Bradfield, whereas the interactive online courseware, this is just another thing. So, I don't know if you want to talk about that, so we can.
Oh, I can do. Yeah. I mean, what this reminds me of, I guess, is the circa 2013 craze around massively online. What's the other O? Massively online courses.
Open online.
Yes, that's right. Yes. Massively open online courses, commonly abbreviated as MOOCs, which were, all the rage in 2013, in the sense that it was a really provocative idea that anywhere with an internet connection, like anyone could subscribe to classes from the top universities in the world and just sort of educate themselves. And it kind of, in some ways, has delivered on the promise. Like, that's still true. It's still very possible that all the great educational content is online. But, there are some critics that might point to like, oh, look at the relatively low sort of course completion rate, which is, I think, roughly around 10%, give or take, and say that it's largely been overhyped. How do you respond to that? And is your online course, attempt to try to do that again, like a V2 of that? Yeah,
so I have a lot of thoughts.
Go for it. Yeah, this is what the show is about.
So MOOCs have delivered a lot of value. What they have done is taken something that was restricted typically to those who had a lot of money or geographical access to well-established institutions, and taken basically university lectures and made them available for anyone with an internet connection. So this is great and unsatisfying. It is great because there is some value in university lectures. It's unsatisfying because we could be doing a lot more online than just delivering video, which you watch. And don't tell me that Coursera has little quizzes at the end or whatever, because as one of my colleagues has put it, it's basically just checking that you're not dead, that you're not that you're not a zombie, that you did in fact remain breathing
like
alive during that time. Yeah, it's like a captcha. That's a good way of putting it. So, like university lectures sprinkled with captures, this is not the best that we could do online. And so, of course, we have a really abysmal completion rate, because if you think about it, we really have an abysmal completion rate of university lectures where you're basically just pushing yourself through it, attending if you really need to attend, if there's like a graded attendance or whatever, and the mandatory attendance, and then you have an exam and you memorize what you need to for the exam and then forget about it, and don't recall anything. If you actually look at if you think right now about some of your favorite courses from university, which was not that long ago for either of us, and consider how much of that do we know, how much of that did we actually learn, it's very little. And a lot of that is due to the fact that it's delivered primarily in this lecture kind of style. And then if you think about what are the skills that you still have from that time, invariably the skills that you picked up in lab work, in assignments and projects where you're actively doing something, not the kind of lectures that were delivered. So to take probably the worst part of it, my perspective is on computer science programs, and a lot of MOOCs are computer science oriented. To take the worst part of a computer science education, the lectures, and to just make that, deliver that at a higher scale, I don't think it's great. So it's a kind of unfulfilled promise. And my favorite MOOCs, the best MOOCs in my opinion, are those that are totally oriented around the work that you do. So like NAD to Tetris is excellent. If you haven't heard of this course, the premise is that God gave you NAND gates, and from there you build Tetris or an equivalent like a game from scratch. You use your NAND gates to build high-level circuits, and you build a little ALU and a CPU, and you write a little compiler and or assembler first and compiler. You build the whole thing. Right? So the course is based around building a thing, and so it's reasonably successful as a MOOC. So anyway, all of this is to say that the thousands or tens of thousands of MOOCs that we've seen appearing that are of minimal value are mostly a translation of the lecture concept, the lecture style. They're mostly done by lecturers. Like if you go through the MOOCs, the people who are delivering these are people who've been delivering lectures for 10 years. The way that I'm approaching it is to figure out how to take a tutorial or a lab and something that is actively worked through by a student and make that the thing that we scale, make that the thing that you experience online. So that means a really tight integration of the pieces of video that help you and explain things and move you through, and the actual exercises, the actual challenges. Really thinking firstly, what is the challenge that the student is going to have, and only secondary to that, thinking how can I help guide? Like first the struggle and then the guidance. Mm-hmm. So this has meant rethinking a lot of things. Built out a custom platform for delivering this, because I don't think any of the existing platforms can deliver the kind of interactivity that it needs. Mm-hmm. I built out a custom system for capturing this, because I think it involves a lot of very small snippets of video that would be impossible to edit in the conventional way. So I do the editing in the command line and the capture through a system that I built myself. So all of it is kind of rethought from scratch with the basic idea of let's make the lab or the tutorial the thing rather than the lecture the thing.
And how are your alpha testers responding? What do they think of it?
It's early days, but I'm heartened by feedback along the lines of this is better than the online course. Sorry, this is better than the in-person course equivalent that I took with you last month. So, I've had students who take a course and then test the interactive online version, and they prefer the one where I'm not there, even though they would have been able to ask me questions in person. And obviously, we charge much more for our in-person courses than we will for this system, for a course on this platform. So that's been really heartening to see. I've had one tester tell me that experiencing this platform was like putting on the Magic Leap for the first time, which, I guess can say a couple of things. He feels like it's clearly the future, but maybe he also feels like it's too early and the technology is janky and it's unlikely to scale. Anyway, we'll see. But there's some promise there. Is what I'm saying.
That's super flattering. Yeah, the Magic Leap analogy is pretty funny. At least, we can see that they've seen the demo in this case, whereas it's unclear whether that's true for Magic Leap.
Right. Oh no, Magic Leap is shipped. Magic Leap, yeah. Okay. We've got one downstairs if you want to play with it a little later. It's a good product.
Yeah.
Hasn't sold that many. I mean, it's a developer product for
Certainly.
sure. Yeah, it's not like a mainstream consumer product yet. But if you put it on, if you actually try this thing and use your imagination a little bit, it is clear that it's the future. At least you see a window into the future. Like you just need to imagine the field of view getting better and maybe the resolution a little better and so on. But if you can do the technologist's job of extrapolating, that it's going to something like this, something along this vector is going to be as we were discussing earlier, the platform of the future.
Yeah, that explains why augmented reality was so top of mind, I suppose. Well, partially, I suppose.
Yeah, I mean, obviously we've been playing with these kinds of technologies for a little while, and there's a lot of unfulfilled potential there. But we're starting to solve a lot of the core problems that are stopping a platform like this from succeeding.
So what's next for your online course? Is this something that listeners of the show will be able to give a try at some point?
Yeah. I mean, it's definitely. I think it'll be a few more months before anything is released publicly, but we've got a little mailing list going for people who are interested, and periodically I'll send out a tweet, or in the future I'll send an email to this mailing list for more alpha testers. So that's probably the best way to keep track of this. But I mean, I think it's the kind of thing that's really worth investing some time in. So even releasing the first course will be a few more months from now.
And well, I think my reaction is that I would be super excited to test out something like that. The one thing that I like, going back to your thought experiment earlier about favorite courses from university, it seemed like the purpose of human lab assistants was to be able to anticipate what questions you might have. And my intuition says that people could ask a huge spectrum of questions, and that it seems like really intractable to try to anticipate all of them in an online way. Does yours try to solve for that in some way?
Yeah, a little bit. It is a big problem, but just as it feels intractable to anticipate and answer all questions, you would say that it's an intractable problem for a human lab assistant to anticipate and be able to answer all the problems. And if anything, we've got many more advantages working on the delivering of the web over just a single human. The way that I try to do this to address this in the platform is to have FAQ questions and video responses interspersed throughout. So there'll be a kind of main narrative in an exercise or a sequence of videos, and then if you have a question, hopefully it's anticipated with one of these FAQ kind of branches off the main line. And the idea is that sometimes it won't be anticipated as a branch off the main line. And so you'll have an opportunity to ask the question, and then we'll be able to add more of the FAQ responses over time and kind of address those that way. But, interestingly, like putting our computer networking course onto this platform as our first course, and we've been teaching this for 4 years. I've personally taught it maybe 10 times at this point. You can largely anticipate the questions that people have at any point. When we have a new teacher come on board at Bradfield, probably the first 2 or 3 times that they teach a course, they know the material very well. And so they know what they're going to say. They know what that main branch is. But it takes those 2 or 3 times to see what the typical questions are. But after that, you can anticipate the questions. You can imagine. I mean, even if you just see a blank face, You say something and see a blank face, you can probably guess what the question is in their minds. So it's, I think it's a little bit easier than you think, and something that we can potentially solve better with technology than without it.
On the internet, though, you can't necessarily see the blank faces. Is that, I guess, solved for by having the in-person version first to inform the online class? Or
it definitely helps to have taught this a bunch in person. But in the classroom, you need to see the blank face because that person may not put up their hands and ask the question. Delivered online, that person just has a question, and then not in a context where it'd be embarrassing, let's say, to stop the class and say, "Hey, I was lost a little while back. Can we repeat what you said?" They just rewind a little bit and play it forward, or they're presented with those FAQs and they say, "Hey, I didn't quite understand this, and I'll watch this." So again, I think it's a little bit easier to do that kind of thing online.
In person, that kind of behavior, though, it takes some courage, I think, to be able to say in front of potentially multiple classmates that I actually don't understand, and maybe if you could go back, it's tough to do that.
I always appreciate those students because they typically represent a lot of folk, and so if they're not piping up, then there's a risk that you've lost a lot of students, and none of them are saying anything. So to have that courageous soul who says, actually, you've been saying this word system call a lot, but you haven't actually explained what it is. That kind of reminder is really helpful.
How do you encourage that kind of courage in classrooms and even in industry? Like if you're the CTO of your startup and you want people to understand things, how do you encourage the gumption to say, I don't know, could you please explain that?
Yeah, I think it's a lot easier in the classroom than in the workplace, because in the workplace the assumption is, or the maybe incorrect assumption that a lot of people have, is that if they're seen to not know something, then people will doubt their worthiness for that role. And particularly people kind of present themselves as the kind of engineers who deserve a certain job, let's say, and so may tend towards overstating their abilities. And then if they're there and there's some like crack in that veneer, then they see that as problematic. But in the classroom, it's a safe environment where I'm not going to like fire you. You're not going to lose your job. Right. If you ask a question, I'm not making assumptions about what you already know. So that does make it a lot easier. It's always a struggle, but the general idea is that if someone is asking a question, that's good no matter what. It's not that some questions are bad and some questions are good. It's like every question is an opportunity to say, well, like this is how we should direct our learning for this moment. And if you can just create that kind of positive environment, then you start to see more questions. But sometimes that's not the best avenue. Rather than waiting for or trying to encourage courage, instead you should draw out the questions. So I think one of the worst ways to teach, even though sometimes I fall into this trap myself, is to say a bunch of stuff, like talk for a few minutes and then say, any questions? This may work okay if people have this courage and it's already a kind of supporting environment, positive environment. But what tends to be better is to talk less, to ask everybody to solve a problem. We have little whiteboards that students use, so I can very easily say, hey, like just to make sure we're understanding this, actually on your whiteboard, figure this out, like write it down. So that way, not only am I not saying, do we have any questions, and probably not getting a response, not only am I not saying, you, certain person, do you have a response? Or worse, does anyone know the answer to this question? Right. I'm making sure that everyone is keeping up by posing a challenge to everybody. So there are lots of ways that you can do this. You can get everyone to solve something individually. You can pair people up. They can discuss it in their pairs, and then you can randomly pick someone. But there are a lot of better modes for kind of gauging everyone's level than just waiting for someone to have the courage to ask a question.
Yeah, or in your example, waiting for someone to have the courage to answer, which, until you brought it up just now, I hadn't really, it's just been so ingrained in what I consider normal. But now that I think about it, even in my university courses where they were 400 people in an audience.
Yeah.
They still did the pretty standard practice of like asking, like, does anyone know the answer? One person will answer and then move on.
Yeah,
and,
yeah.
You know, could be hundreds of people who are still stuck.
For sure.
Wouldn't matter.
Yeah, I mean, in a lecture, it's really hard. You know, even a lot of lecturers won't even stop to ask a question like that. They just won't think of a lecture that way. They'll just deliver material. And that's the kind of standard lecture experience. And, you know, those who do stop and think, well, this is a good probing question, let me ask it. A lot of the time they will get a response from one person and 399 are lost. You know, maybe some of the better students are at least taking the opportunity to have that question be a kind of probing thing. Even if they don't respond, they're thinking about it, they're engaging with it. But probably 90% are not. You know, you see other lectures, it's very fashionable now to have basically quizzes in lectures where you may have a physical device, you may have a phone app, but basically maybe 2 or 3 times during the lecturer will stop and say, all right, multiple choice quiz, what do we think? And then, you know, that's now encouraging a little bit more engagement. You have to stop and think a little bit. And at the better schools, they'll get people to discuss it in little groups and stuff. And so the lecture will be a little bit more interactive that way. There's only so much you can do in an auditorium. You know, this is like the research shows that having some kind of interaction like that is way better than just listening to a lecture. But it's like a Capture 2.0. It's still how you're paying attention. You know, we have very small classes here, so it's a lot easier to do that. And if you were teaching in a kind of seminar style or tutorial style rather than a lecture style, it's going to be way easier. So, you know, credit goes to the lecturers who are really thinking about this stuff and trying to do a good job of it. In that context, it's hard. Goes back to why the MOOC being like an online lecture is the wrong paradigm. It's the wrong starting point.
I've been asking you to speculate on the future already once. I'll do it again. Yeah. When it comes to like education and teaching, what do you see as like a future state that isn't the one that we have today? Will we have more Bradfield-like finishing schools? Like, let's say if maybe not just for computer science, but for business, you know, if your role is like business development, would you attend a Bradfield for business and sort of fill in your knowledge gaps there? Like what's next for learning?
Yeah, it's hard to know. I think, you know, a lot of people think we're in a university bubble. And I mean, it is pretty clear that too many people are going to university, that universities are too big of a business and they're too highly subsidized and most people should not be doing this. But, you know, I don't go as far as thinking that most people will get their education in some unorthodox manner, like, you know, finish high school, do a boot camp, do an internship, come to Bradfield, or whatever. There are going to be some people who do this, but the universities are in this unique position of bundling together not just an education or an attempted education, but a rite of passage, a nice campus, a peer group, like a social circle, an answer to what are you doing? Like, what are you doing with your life? These things are very hard to cobble together, like to pick a la carte. And we are seeing companies, organizations popping up in all of these categories. You know, not just an alternative to education, which, you know, Bradfield and boot camps and so on are starting to fill, but things like an alternative to a peer group. But it could be that the prefix, the like university bundle, is just better overall as a bundle. Like if you're trying to achieve all of these things, it may be too challenging for you to cobble together all the a la carte pieces in a way that's going to be better or more affordable or more effective, depending on what you want. Now, you may be the sort of person who doesn't care about the social circle and the rite of passage and everything else that you're going to get from university. And I think those are the people who we see who are, you know, working at the age of 19 or whatever. But it's likely that that's going to remain a minority for a while. So I think I'm probably unique in that I'm part of this like alternative movement, but realistic, I think, about how applicable it is to people. You know, for us, we have a good niche, which is self-taught software engineers.
Right.
Other people may not have that niche. It may be the case that there is a niche for like MBA alternatives, let's say, but it also I could easily see the argument to say that's never going to work because the MBA is mostly about the things that a conventional university bundle can deliver that an alternative program cannot deliver. And I think for most 18-year-olds, most people going to university, they're looking for way more than the kind of education experience. And to do that, you need a $1 billion endowment, probably. You need a good campus. And $1 billion is there, not an exaggeration. There are around 100 universities or colleges in the US with $1 billion or more in their endowments. And so if you want to compete even in the top 100 to deliver all of these things at once, right, to be the provider of the bundle, you have to be a huge entity like that. So, many of us are going to compete around the fringes, but it's unlikely that the a la carte combination is going to beat the prefix, in my opinion.
Wow, that's a very nuanced take that I really kind of didn't expect. Well, one part of that sounds like being that there will kind of always be a place for college, and this bundle of things will always make sense for some people. But it sounds like the future could be certain parts of that package being decoupled from the rest and offered as their own services, kind of like how Bradfield is.
Yeah, I think so. I mean, I can totally see a situation where people go to university and don't learn anything from their university, but use that as a safe environment to do what you do at that age while learning online from some other institution. I actually anticipate this. I think that once our courseware is available, our self-paced courseware is available, I anticipate a lot of undergraduate students who are taking a computer architecture course, let's say, not learning from their computer architecture course, learning instead from our courseware, and just going and doing their exams and getting their credentialing and whatever from the university, all in a nice campus that we can't provide to them downtown San Francisco and Soma, in an environment where they can that afternoon go and watch football or whatever, something that we can't do. All these pieces of their undergraduate experience that we can't provide. So.
Yeah, well, a couple of things. Number one, in some ways that's what happens today, where it's shocking how even a university, Khan Academy is such a huge, fabulous resource.
For sure,
because it covers all the things that you didn't understand in lecture.
Yeah.
And the second thing is who knows? Bradfield could have a huge campus one day. Am I wrong?
Yeah, I mean, I think I'm tending away from that.
Okay.
I think I really enjoy the education aspect of this, and I'm realizing that that's a tiny sliver of what people are looking for in this undergraduate bundle. But that's what I enjoy. That's what we enjoy doing here, actually effective teaching. We don't do any kind of credentialing, and that's maybe much more significant aspect of the bundle, like getting the degree, getting the stamp. But we don't want to do that. We don't want to deal with accreditors, and we don't want to restructure our courses in a way that the accreditors will approve, but which will degrade the educational experience. And then to consider all of the costs and distractions of everything else that's going on in the campus. I think other people can do that. That's not the vector that we want to compete on. So, I think for anyone who's interested in working in this space as well, that would probably be my suggestion. You're never going to make a full frontal attack. You want to find the kind of angle that's interesting to you and that could be valuable. And it's going to look very different to a traditional educational institution for sure. Not replacing it, but maybe replacing a little piece of it.
That's such an interesting note. We are at the point in the interview to start the lightning round.
Okay.
As the name suggests, it's just typically where answers are a bit shorter and the questions are a bit more provocative.
I make no promise of providing a short answer to a
That's
question.
Perfectly fine.
We'll do what we can. Though.
Yeah, that would not be too different from the precedents. Why don't we start with your favorite teacher of all time for yourself?
This is one of my okay. So this is not going to be a short answer. I apologize.
Go for it.
Because this is one of my favorite questions to ask other people, but also a very challenging question to answer. I'm always curious about people's responses, but by and large, the responses that I get when I ask this question are people like Richard Feynman. More recently, Grant Sanderson, 3 Blue 1 Brown on YouTube. It's kind of interesting that these are comparable, but people like that. Walter Lewin at MIT. Who else? Bob Ross, the painter. These are people who are all charismatic, teachers, maybe with the exception of Grant Sanderson, they're all kind of entertainers, really. Like if you see Walter Lewin's lectures, they're performances. This is not teaching, in my opinion, and people are not learning when they experience this thing. But there is a little bit of an aspect of motivation where these performances are engaging, and so people maybe want to like explore the topic a little bit more. That only works, that's only valuable if the motivation leads to that guided struggle ultimately. These people are not providing the guidance. They're not encouraging the struggle. They're kind of taking the struggle away from you, actually, by trying to present a kind of neat, packaged up metaphor or explanation of something. The like Feynman metaphor takes the struggle away from you because now you're no longer grappling with what is this thing. You have like his version of what this thing is. So anyway, I think all of those are the wrong answer to this question of like, who is a good teacher? Who's an effective teacher? The people who do the opposite, who like encourage the struggle or provide guidance around the struggle, have not achieved the kind of scale of Richard Feynman or Grant Sanderson. I can't believe I'm saying those two names together, but that's it. Like, whether it's the like new generation of people making excellent videos on YouTube or the old generation of people giving lectures at Caltech, it's hard to achieve that kind of scale if what you're doing is guided struggle. But, I want to give you an answer, like who is my favorite. And in that context, maybe someone like Scott Galloway, do you know this? In a Game of Tennis?
Scott Galloway.
Yes, Galloway, sorry.
Is he the professor at NYU or is that a different Scott Galloway?
No, he is a tennis coach.
Tennis coach.
Yes.
Okay.
Maybe he was. I don't know if he's still around.
For sure.
I mean, he's known for this book, The Inner Game of Tennis.
Okay.
But you can see videos of him teaching tennis. And the premise of his teaching and of the book is that the way tennis was taught until then is entirely wrong. That if you're a tennis coach and you are providing feedback that's along the lines of hold your racket this way or elevate your arm or like specific like verbalized piece of feedback about your movement, then you're doing it wrong. That's what you need to be doing is providing a context where the student, the learner, the player is getting feedback on their activity, and their activity is playing tennis. Their activity is hitting the ball over the net. So you got to feed the ball in a way where like get a lot of reps that are well calibrated. The ball's moving at the right speed and so on, and they're hitting them over the net. And gradually you do this, and you find ways to do this with serving and volleys and every aspect of tennis. So I think, The Inner Game of Tennis is now a relatively popular book outside of tennis and, in fact, outside of sports. And I think it's influenced coaching. And so kind of at a meta level, he's one of these few actual teachers who was effective at teaching tennis, like individually to tennis players, but also embraced this style of guided struggle of, he's feeding you the ball and that's the guidance. The guidance is not like do this specific thing, because your body's better at learning this thing than your brain is at adjusting to the feedback. And then embracing that struggle. You do need to hit a lot of balls over the net.
That reminds me of something I've always thought that was unusual. Like if you're ever watching tennis and you see whoever the best player is in the world at the time, no matter what their swing is, the commentators will always say, that was textbook. What a textbook backhand.
Right.
But does that change every time there's a new world number one? Like,
yeah.
And then like they'll say other players are unorthodox. What an unorthodox backhand.
Yeah. But
they're pros. They're some of the best people in the world.
Yeah.
What is textbook?
Yeah, what is textbook? I mean, to me, the hilarious thing about that is, could you imagine a textbook that describes like Roger Federer's
you're just constantly changing.
Yeah.
Edition 300.
Yeah.
Now this is how you play tennis.
Try verbalizing that, like writing a textbook on Roger Federer's forehand or something. Like it's just a fanciful thing to do, to try and think that we can capture whether it's tennis or physics or computer science or whatever in that kind of description, rather than in the doing of the thing.
All right, next one.
Okay.
What are you dressing up as for Halloween?
I am Australian. I have not fully bought into the American holidays. Halloween is one of them. Although we were at a kid's Halloween party with our 7-month-old, and she was dressed as a giraffe. So there's your short answer.
All right.
Yeah.
Lastly, what is the best programming language?
That is a provocative question, and of course the answer is Lisp, no. Of course, the answer is that there's no best programming language, and you got to pick the right one for the job, and that is Lisp. No. You got to pick the right one for the job, and for a lot of people right now, that's Python, just because there's an ecosystem built up around that for the kind of jobs that people are doing, and that's a combination of web development, for which Python is reasonable, and data science, for which Python is reasonable. But then if you're writing a game, you're going to do that in C or C++ or something, and if you're writing a piece of firmware or microcontroller or something, you're not going to write in Python. So obviously you need to think about this. But yes, it is probably not Lisp.
Spoken like a true educator. Well, I'm afraid that's basically our time. If folks want to follow you and Bradfield and your thinking, where should they go?
Yeah, my Twitter is OzNova with an underscore at the end. I'm sure it'll be in the show notes. Bradfield is at bradfieldcs.com, or you can Google for Bradfield. Those are the two best places. We've got a little mailing list.
OzNova, thank you for your time.
Thank you.
What a guy, am I right? I am still thinking about some of the things that we talked about, including this claim of his that you can't be both entertaining and a teacher, because people who are too entertained, like folks who are listening to a Richard Feynman lecture, are not actually learning, is the claim. I've been thinking about that one for a while, and it's been rolling around in my head. And if it has been in yours too, I'd love for you to tell me about it. You can do so by tweeting at us. We are at BusinessLogicFM on Twitter. And if you enjoyed the show, please listen to the other ones and also rate us on whatever podcast app that you happen to be listening to. See you in the next episode. Cheers.